Hello everyone, welcome back to In My Shed. I'm BC. I'm going to start a bit of an article on making a drill grinding and tap grinding attachment, very similar to the Clarkson item. I don't have one for the Clarkson grinder. I envy one. I really would like one, but not available on eBay or anywhere around. I have asked a question for one that's for sale overseas, but so far no reply. I don't know whether they'll split it off the grinder or not, but if I can't get that, I'll have to build it. I've got a few easy steps. The spindle will be quite easy done. Just take the spindle out of the workhead. This gives me a ER32 collet chuck, and I've already got the indexing plate for the back of it, although I will have to make more indexing plates for different taps. But having a spindle done to a specific size and well ground is a really good start. I've done a bit of a scrounge around the shed this morning and had a look. I've got most of the material I need. I'll just use a piece of plate for a base, a piece of 75mm pipe for the riser, cut that off at an angle, and I've got quite a good sized billet of steel that I can use for the main body, giving me enough meat for the handle on the side. So when I finish prattling here, I've got a photocopied instruction manual for the drill and tap grinding attachment laid out on the bench. It's got a terrible photograph, but it does have a line drawing, and I think the line drawing will give me the included angle and the convergent point for the eccentric pivot, which is pretty well all you need. There's a very good YouTube video put up by a fellow called George Hegg, H-E-G, and he shows one of these grinders in operation, and if you go to that video and have a look, you see why I would like one. The converging point puts the tip of the drill being ground at a set distance in front of the collet chuck, and as I have an ER11 collet chuck, it will allow me to go right down to 1.5mm drills, which is a bit of an advantage over what I have at the moment. Anyway, this will be the first instalment. We'll have a bit of a rough look. I don't have any actual works drawings, and I might put a bit of a sketch together, but so far nothing to show you. But I'll show you the drawings and the handbook, and I'll also show you some of the material I've got. So back soon. I'll turn the camera around. Here we are back on the workbench. At first I thought I had it made. This is a homemade workhead that came with the Clarkson grinder, and it's got a spindle in there at the moment for doing big deadlock cutters, and I've got a mismatch of spindles, etc. The only problem is it's made with a 1-inch bore, and the collet chuck I want to use is 25mm, so that discounts using something that's easy. That's just the way of life. Okay, spin you around to this horrible photograph. We'll see if we can get it a bit closer. That should be good enough. That's a terrible photograph, as I said, of a Clarkson attachment. That's the base on the grinder table. There's a casting which forms the riser. Here is the main body, and there's an eccentric over the back. Now, as I said, if you get on to YouTube to George's video, you'll get a much better picture of this. That gives you the layout with it on the grinder, and that's the cam plate for grinding taps. It can also do countersinks, and I've shown this sort of setup on my Clarkson workhead in a previous video on tool and cutter work. So the principle has been proved by Clarkson. There's a lot of interesting little devices built into this. There is a locking arm that drops into slots at the back to lock the drill into position. Makes it very easy for split pointing, etc. I think there's a lot of design going into this attachment, a lot of good thinking. I'll spin you down to the line drawing now. That I think is a line drawing courtesy of Clarkson, and the interesting part of it is they give you a bit of an idea of the angle between the two parts. That's the pivot point there, and this is the main body with the spindle through the middle. So I'm going to put the protractor up there, see what they suggest in this drawing is the correct angle to put between them. Now this is similar to what I've been doing grinding tools on the Clarkson. This thumb screw locks the dividing head or spindle at the back to the main shaft. So you put your drill to be ground in the chuck, you get the drill point level with the table, you then lock the thumb screw here, and that times the slot in the back to the body, to the spindle, to the drill. So very, very simple setup, and I think it'd be a good thing to have in the kit. That's a bit better. You can see the drawing of the chuck on the front. So we'll go over to the old borer table, the only flat thing in the shed that's not covered in rubbish, and look at some of the materials I've got. Back soon. G'day, back again at the borer. Well, I rounded up some material to do the job. Nice bit of flat steel for the base plate. That can be a base for the pipe to be welded to, and a nut through the middle. I'm going to cut one side of the pipe away, so I'll have a nut at top to rotate this around. This will make a nice main body, and I'll cut it to the same length as the head that I've got on the Clarkson at the moment. That way the spindle can go in with enough room at the back for the indexing head, and a couple of bushes welded on top of the pipe for the spindle to go through. So enough to start. I'll have a bit of a think, cut this size, and then bring you back when the machining starts. Bye for now. Here we are at the PO Parkinson power hacksaw, cutting us some pipe for the riser for the drill grinding attachment. It's an old dinosaur like me, but it does the job. You can't go too quickly into steel pipe as the crickle's not really good on the side. I actually had a piece of 6-inch pipe turn in the vise and come loose, so it's a bit of a steady break. And I had a big piece of boiler pipe up in the vise a couple of weeks ago, so I finished the job, making the borer's place, and now I can start to do that. We'll be back when we got the solid in there. And here's the old saw, cutting up the billet for the workshop. When I first started collecting machines, these old dinosaurs only cost me $300 to $500. I think the shaper was about $600, and even straight out of Melbourne was only about $200 or $300. But now the hobbyists are seizing as many items as they can, the price is on through the roof. Okay, we'll just put it up on the dollar table and do a bit of an explanation. G'day guys, back again. Put the hat into high speed mode. Look, the items are assembled up on the borer table, so I'll zoom you in and we can have a bit of a look how we've done so far. And there we are. Okay, what have we got so far? We've got a bit of steel for a base. You've got a base plate for the column. That'll have a pivot bolt through the middle of it. Then we have the body up on top, and you might just faintly see a bit of engineer's chalk with a big piece cut out of it. That'll allow me access to get at the nut. Up the top I'll machine it so that the bar fits in, weld the bar in place, and then make a cut in the middle. And this could be the connecting part to come across, oh, it's still hot, to the workhead. So I've got enough material at least to start. I'm thinking about offsetting the 25mm bore from the centre of the workhead, because I've got some features to put on it. I've got a handle to go in, there's got to be the slide up cam plate for doing taps and countersinks, and also a latch in the top. So I'll have a think about offsetting it so I don't have to go welding blocks on the outside. If I can make all the features fit into the solid piece, I'd be a lot happier with that. Also, I'm filming this last segment without all the extra light, so let me know if that's good enough or not, so I'll know whether to do it in the future. I know the shotgun mic made a hell of a difference. Okay, that's a start. Too bloody hot and humid to keep on going today. I reckon I've lost about 3 litres of water so far. Okay, bye for now. Please like and subscribe.